This question 5 can be a bit tricky, so as long as you know your factor theorem well, you should be okay. And this part A, there are many ways for you to go about finding alpha beta. I opted for this by factorizing this x squared plus 1, and I would get this or this because we're not sure which is which. And then how do we use part A to show this particular statement? One way is by letting this expression be the gx, okay, and you show that g1 is 0 and gi, and g negative I is 0 also. And since this is the case, by factor theorem, we therefore know that then these two are factors of the polynomial gx. And from A, we know that x squared plus 1 is in fact a product of these two factors, and so it itself is also a factor of gx. Okay, got it? Now, part C here, pretty straightforward. Span this left-hand side, or right-hand side rather, and just compare left and right sides, and you get tx equivalent to 1 minus x. And so, hence means you need to use the result, find the remainder, and we know that x to the power of 2010 plus 1 is has a factor of x squared plus 1. So therefore that means that this expression can be expressed as x squared plus 1 times some polynomial hx, let's call it hx. And so what we do is we substitute this expression into the other expression 2011 plus 1, and so work on this and divide the whole expression later, or equation rather, by x squared plus 1. You end up with this, and so this is the divisor, x squared plus 1, and the hx is your quotient, and therefore the 1 minus x is your remainder. Okay, now better read up on this on factoring remainder theorem. Now question 6, inductive argument is always a challenging question for students, and I call this identity 1 because I know I'm going to refer to it later, and see that how very carefully I write this. Sine to the power of 2 square theta is sine 4 theta. There is a reason I do this. I'll talk about it later. And I purposely write as a 2 times 2 theta. And here I use a line 2 and 3. I actually use the identity 1 twice. And I got to this 4 sine theta, this expression. And for the next one, I purposely write 2 to the power 3 theta. I mean, I want to relate that pattern. Okay. And here again I write 2 times 4 theta because again I want to relate that particular pattern. And you see that actually in this third line right here, I'm using or use the result from part 1. That is this one, the sine 4 theta, which something we shown right here, at top here, and I use it right here, and I got this. So what does that mean? When we try to do the inductive argument part. So here I show that sine 16 theta can be proven, according to this formula, by using the result of sine 8 theta we got from part A2, as I written here. And so we can see that therefore if for a term which looks like this, then the next term would rely on it, right? The sine 2 to the power of n theta would rely on this one here, and then we got this, and so we know that by inductive argument, this formula we can use that to deduce or induce the next formula, the next term, and therefore we say that this formula is correct for all positive n. And the last part is just using the formula, here, and beware of 64 here is 64 square as you work on the problem. And the next one here is, okay, I'm going to draw this straight away. Start from the point given, so follow the slope field as to your best ability. Okay, right, and you can use a ruler to check or recall the method I share with you, how you check this, how good your slope, your sketch is. And the next part, now just using calculator, make sure you know how to use it and read from the calculator, inputting these values, all this. And this is of course the estimate from the Euler method is an underestimate, and that's 1 mark. And now how do you get a second mark? And you need to justify your answer. So what I would suggest that you use the fundamental theorem and then use the technology, okay, and then show that the value that you got, roughly 1.1023, is greater than your estimate using Euler right here. So that's kind of support your claim that it is an underestimate. And the last one is, well, just perform more steps of Euler method. So I see you at other videos, and all the best again.